Hello everybody in middle one. Today inshallah we will talk about the first lesson in algebra is called the set of rational number. This is a new set of rational number. Rational number. But in the first, let's remember from the previous study counting a number. Counting a number, it's a symbol C. Start from 1, 2, 3, 4, 5, and so on. And in junior 5 we talked about natural number. Start from 0 and 1, 2, 3, and so on. And in junior 6 we talked about Z, integer number. Integer number, 0 in middle, 1, 2, 3, and so on. These positive numbers, and we have here negative 1, negative 2, negative 3, and so on. So we have here this counting number and this natural number and these integer numbers. That about previous study. But if we talk about the new rational number, new set of number is about today. Numbers of today is called rational number. Rational number, and it's a symbol Q. It's a symbol what? It's a symbol Q. This number, any number, I can write it as A over B. A over B. Any number I can write as A over B is a rational number, like 2 over 7, 1 over 5, 3 over 8, 5 over 11, and so on. So any number I can write it as A over B is a rational number. But we have here the number in up integer and down integer. So we have here condition is very important. I can't write in down 0. So we have here expression. It's very important. A over B, where A and P belong Z. But we have a condition B doesn't equal 0. B doesn't equal 0. And down we don't have any 0. How? 3 over 0. 3 over 0. It is not rational number. 5 over 0. It is not rational number. So we must put 0 in down. We must put 0 in down. So if we have a this condition, it's very important. It's very what? It's very important. 0 over 3 rational number, but 3 over 0 it is not rational number. It is not rational number. We have here our integer number Z. 0, 1, 2, 3, and so on. And we have here negative 1, negative 2, and so on. All integer number denominator 1. Denominator what? 1. So all integer number, all integer number are rational. Are what? Are rational. Are rational number. Or rational number. So let's move to our condition again. I have A over B, where A and B belong Z, but B doesn't equal 0. This condition is very important. So we have here some example. If is the first example. If 3 over x minus 2 belong q, is a rational number, then x doesn't equal what? If we talk about this all rational number is q, so look at down. Look at what? Look at down. Look at here. Down here doesn't equal 0. So x minus 2 doesn't equal 0. As equation, transpose to the other side with opposite sign. So x doesn't equal 2. So my answer here 2. Another example, if x minus 2 over x plus 7 belong q, then x doesn't equal what? I said this is all rational number, this is q. So look at down. X plus 7 doesn't equal 0. As equation, go to the other side. X doesn't equal negative 7. So our answer here, negative 7. Another example, 3 over 2x minus 3 belong q. So x doesn't equal what? Take the denominator, 2x minus 3 doesn't equal 0 because it's rational number. And as equation, 2x doesn't equal 3, x doesn't equal 3 over 2. We have here information, it's very important. This is about x over x minus 2 belong q. You see q, you answer in down. But if we have this example, x minus 2 over 5 equals 0. So look at up. Look at up. X minus 2 and equal 0. Go as equation, x equal what? 2. So our exercise here, number 1, x minus 3 over 5 equals 0. So x equal what? I said equal 0. Equal 0, so look at up. Look at up. Your answer in up. X minus 3 equals 0. Suppose x equal 3. This is your answer. Number 2, I have x plus 7 over x minus 3 equals 0. I said equal 0, so your answer in up. X plus 7 equals 0, and go x equal negative 7. But number 3 here, x plus 7 over x minus 2 belong q. Then x doesn't equal what? Here I said belong q, so my answer in down. X minus 2 doesn't equal 0. Go x doesn't equal 2. This about this point. Let's move here. The set of counting number and the natural number and the integer and the rational number. I can express that a over p, where p doesn't equal 0. And we have here all decimal number are rational number. All decimal number. All decimal number? Yes, all decimal number. Like, if I have 0.2, 0.2, write 2 over 10. This is a rational number. 0.3 is 3 over 10. 0.5 is 5 over 10. A over b, a over b, a over b. So any rational number, any decimal number, a rational number. Any decimal number are rational number. Let's explain this point. We have here 0.2, 2 over 10, 0.3, 3 over 10, 2.5, 25 over 10. Then all decimal or rational. And all percents. We have here 50%. 50%, I can write it 50 over 100 from Junior 6. After simplify, 1 over 2. A over B, so this is rational number. 30%. 30%, I can write it 30 over 100. So 3 over 10. A over B is rational number. So all percents are rational. All percents are what? Are rational number. All percents are what? Are rational number. All integer are rational number because any integer number, the denominator of it is 1. And we have here this drawing. Here the big circle here, Q rational number, contain integer, contain natural, so N natural number, subset of integer, subset of rational number. And we have types of decimal number now: recurring decimal and terminating decimal. It's very important. What's the difference between recurring decimal and terminating decimal? Recurring decimal, I have 1 over 3. If you write this as your calculator, you have 0.3333333, and we have here 3 is repeat. So any number repeat, put point of it, and you read 0. Recurring decimal 3. So we have here 0.3 recurring. 3 what? 3 recurring. 0.3 dot. We have here 2 over 3. 0 point. This means 0.6 and 6 and 6 and 6 and 6 and 6 and 6. So all these numbers 0.6666. How I can write this? 0.6. Put dot up of the number is repeated. Here 2 over 11 as the same way, 0.18. This means 0.1818181818. So answer 0.18. Put it here and it here. This is called recurring decimal. This is called what? This is called recurring decimal. But if you want terminating decimal, this point, if you write 3 over 4, you have 0.75 just this terminating decimal. 0.4 just terminating decimal. 0.125 just terminating decimal. 1 over 4, 0.25 just this terminating decimal. And about this example, x over 5 equals 0. So look at up. So x equals 0. But if I have here x minus 3 over x plus 7 equals 0, then x, I said equals 0. Look at up. X minus 3 equals 0. Transpose. So x equal what? Equal 3. This is about today, and thank you. Thank you for the lesson.